Hello. So in this module, we understand what is a semiconductor. So a semiconductor is a material which has an electrical conductivity between that of a conductor and an insulator. So we know that conductor materials such as copper, iron, steel, etc. And insulators are examples are the glass, rubber, wood, etc. So semiconductor is a material which has a conductivity or say a resistivity that lies between that of a conductor and an insulator. So semiconductors are used to control and manage the flow of electric current in electronic equipments and the devices. So there are examples of the semiconductors such as gallium arsenide, germanium, and silicon. So these are the semiconductors. So now let's understand the operation of the semiconductors, how they work. So here shows a picture of the energy band diagram. Here you see that energy unit of which is EV, and it starts from this end to this end. So the first part of the picture shows the energy band diagram for a conductor. So the dark gray shade indicates a conduction band, and the dotted white shade indicates the valence band. So the valence band is full of charge carriers such as electrons or the holes, which will make the conduction possible. And these two bands, conduction band and the valence band, in a case of conductors, are overlapped with each other. So it is easier for the charge carriers to jump from the valence region to the conduction region. So there is a easier flow of current or electricity in the case of conductor. In the third part, we have a case of insulator. So in insulator, you have a conduction band region and the valence band region where charge carriers are present and they want to go from the valence region to the conduction region. But to do so, they need to overcome a large energy gap that is there. So energy gap is greater than 5 electron volt. This energy needs to be overcome for these charge carriers right here so that the conduction in insulator can be possible. So there is a strict requirement. That's why insulator, as we know, they do not conduct the electricity as easy as the conductors do. But in between the case, in between, we see there is another case, another material right here, which is called as semiconductor. So why we are calling it as a semiconductor, let's understand. So we have this dark gray shade region, which is a conduction band, and this is a white dotted region, which is a valence band of a conductor. But as compared to the insulator, in a semiconductor, the energy band gap is much smaller. So it is less than what is indicated right here. So you need to the charge carriers present in the valence band, such as electrons, for example, need relatively less energy to overcome this region and overcome this gap in order to jump to the conduction region and to carry the electricity. So it is possible with the semiconductor by means of doping or by means of temperature increase, we can make the charge carriers jump from the valence region to the conduction region. That's why we can control and manage the flow of electric current in semiconductor, and that's why they are a great choice to make the electronic equipment, devices, circuits, and systems.